Welcome to this explainer. Today, we are diving into what is honestly the hidden hero of the polymer processing industries, the extruder screen. Look, if you've ever handled a perfectly flawless piece of plastic film, a smooth PVC pipe, or literally anything made from recycled plastics, you've directly benefited from the invisible, microscopic battle we're about to talk about.
So let's kick things off with a massive manufacturing challenge. Imagine you've got this huge industrial machine processing raw plastic pellets. These pellets are melting at blistering temperatures. We're talking 200 to 300 degrees Celsius, and they are moving under immense pressure. Now, inside that molten river of plastic, you've got microscopic contaminants. We're talking unmelted granules, gels, little carbon specks, maybe even tiny metal particles. If those impurities make it through to the final mold, your end product is completely ruined. So here's the million-dollar question. How on earth do you stop microscopic contamination in a molten flow without bringing your entire production line to a grinding halt?
To answer that, we're going to lean on the expertise of Ambica Group. They've been India's leading extruder screen manufacturer since 1972. With over 5 decades in the game and exporting to over 65 countries, they are the perfect guide to help us unpack exactly how this filtration technology works and, more importantly, why it matters so much.
Okay, Section 1, the extruder screen basics. Let's get right into it.
Think of this screen as the ultimate bouncer for the plastic, rubber, and recycling industries. It's essentially a woven wire mesh disc, or sometimes a stacked multi-layer pack, wedged perfectly between the rotating screw barrel that pushes the molten plastic and the die head that actually shapes it. Before a single drop of material can become a final product, it absolutely must get past this metallic gatekeeper.
Moving right along to Section 2, core functions and materials. This proper filtration acts as a literal bodyguard for million-dollar machinery. By trapping abrasive particles right at the start, the screen prevents them from completely chewing up sensitive extrusion dies or gear pumps. So it's not just about keeping the plastic clean, right? It's about machine health. It also stabilizes the back pressure and keeps the melt uniform, which gives you those perfectly consistent dimensions and wall thicknesses in the final product.
Now, the DNA of these screens comes down to the materials. And the undisputed heavyweight champion here is SS304L, the industry standard stainless steel.
Ambica Group specifically uses SS304L because its high tensile strength is practically unmatched. It handles immense back pressures, often anywhere from 500 to an incredible 5,000 psi, and it does all this without chemically reacting to the polymers. You definitely can't just toss mild steel into a 300-degree plastic flow. It would rust, oxidize, and instantly ruin the batch. By the way, the L in SS304L actually stands for low carbon. Combine that with a high 8% nickel content, and it holds its structural integrity up to a mind-blowing 870 degrees Celsius. Plus, its corrosion resistance is a huge deal for things like food-grade packaging compliance.
Let's jump to Section 3, weaves, meshes, and shapes.
So, not all screens are woven the same way. You tailor the weave directly to the specific polymer you are running. Plain weave is your reliable go-to for general support and virgin plastics. But if you need finer filtration and the sheer physical strength to take on heavy pressure, you swap to a Dutch weave. And for the absolute finest meshes where you also need flexibility, twilled weave is your engineering choice.
And that naturally brings us to the mesh count. Depending on the precision you need, these can range from a coarse 10 mesh all the way down to a microscopic 500 mesh. Just to put that into perspective for a second, a 500 mesh filters down to roughly 2 microns. That is literally smaller than a single human hair. Now, if you're processing super clean virgin polymer, a coarser mesh is totally fine. But if you're in, say, plastic recycling where contamination is everywhere, you'd probably use a spot-welded multi-layer pack. You'd stack a 20, 60, 160, and 20 mesh all together to get this incredible graduated filtration.
Visually, you're mostly going to see these as single or multi-layer circular shapes, designed to pop perfectly into standard breaker plates. And precision here is absolutely crucial. The dimensions have to match exactly. I mean, even a single millimeter of variation means the molten plastic just sneaks right past the filter entirely, or you get these massive pressure leaks.
But hey, the standard circle isn't the only game in town. Custom sizes and totally wild designer shapes, like cylindrical packs and uniquely molded screens, are developed to meet highly specific machine specs. Whether you're running high-volume pipe extrusion or some highly specialized master batch processing, the screen physically has to conform to the machinery's exact architecture.
All right, moving into Section 4, performance and maintenance indicators. A high-quality screen is basically your best friend on the factory floor for minimizing machine downtime. By capturing those abrasive particles, you extend the life of your expensive dies and take a ton of stress off the gear pumps. But honestly, the biggest win is uniform product dimensions. Whether you're making a paper-thin film for food packaging or a rugged agricultural pipe, that consistency is exactly what keeps an operation profitable.
But on the flip side, getting this wrong is a total recipe for disaster. Let's say you cheap out and use an aluminum ring frame in a high-pressure setup instead of a proper spot-welded pack. That frame is going to deform. The mesh layers separate, the plastic bypasses the filter, and boom, you've got a ruined batch. Or even worse, the screen just ruptures entirely, firing all those trapped contaminants straight into the machine at once.
To stop those catastrophic ruptures, operators have to watch a vital checklist of warning signs like a hawk. The most obvious one is rising back pressure at the breaker plate. That actually means the screen is doing its job and filling up with junk. But if you start seeing falling output rates, crazy spikes in melt temperature, or actual physical defects like gel streaks and black specks in the plastic, yeah, the screen is overloaded and needs to be changed out immediately. Keeping an eye on these metrics is how plants create bulletproof replacement schedules.
And finally, Section 5, Industrial Applications and ROI.
Who actually uses these things? Pretty much everyone. They are an absolute necessity for producing grocery store packaging, PVC plumbing, rubber tires, and wire cabling. And with the entire globe pivoting heavily toward plastic recycling right now, the demand for high-capacity, multi-layer screen packs has literally never been higher, just to deal with all that naturally heavy contamination. When we talk about ROI, it is just incredibly clear. Getting the right screen reduces waste, protects your heavy machinery, and keeps the whole operation in the green. A facility manager really shouldn't just look at the price tag of a single piece of wire mesh. They need to look at the total production cost per ton. Sure, a premium SS304L screen might cost a tiny fraction more up front, but it pays for itself tenfold by stopping machine downtime and material rejection dead in its tracks.
It is just wild to think that a component as thin as a coin can dictate the absolute success or failure of a massive industrial operation. So I'll leave you with this. Are you underestimating the most critical first line of defense in your machinery? The next time you grab a perfectly clear plastic bottle or see a flawless rubber tire, you'll know exactly the microscopic battle that made it happen. Thanks for joining me on this explainer, and keep looking for the hidden brilliance in the machines around us.